Good morning, everybody. Everybody got some eggs? All right. So the intro to the first panel said that we're going to start off without a lot of code. I'm going to continue that tradition. So I'm going to be talking a little bit about economics and the economics and governance design in blockchain. So my name is Stephanie Herter, and I'm a founding economist with Prysm Group. So we're PhD economists, and we do economics and governance design for blockchain. So we do a combination of advising, research, and education, sort of trying to bring economics into more of the blockchain community. So I did a PhD in economics at Harvard, and as you gather from me standing here, I work in blockchain. And a lot of people are very surprised when they meet me and my business partners. And we get asked a lot, sort of, how did you end up here? You know, what are you doing here? You're kind of a unicorn. Why do you work in blockchain? How did this happen? And the answer is actually very simple. So, you know, blockchain projects are economies written in code, right? Most blockchain projects, if not all of them, are trying to deliver some kind of economic value, right? So you're you know, getting a good or service, you're mining in exchange for profit, you're conducting decentralized trade, right? And so this is incredibly exciting because when you're an economist working in blockchain, you get to constantly reimagine how you want the economy to look. You know, and the vast majority of economists that I know, you know, they finish their PhDs and they go work at the Fed or they go work at eBay or Amazon, where they're going to spend most of their careers working on the edge of one or two markets, right? Maybe they work on the housing market or they help decide monetary policy. In blockchain, we're working on dozens of different markets and economies every day. We're introducing currencies all the time. So this is an incredibly rich and exciting place to be. And one of the things I've noticed, you know, we partner with a lot of technical teams, computer scientists and engineers, is that economists and computer scientists approach platform design in a fundamentally different way. And let me tell you how. So, you know, the study of economics and especially microeconomics, so just as a side note, I was talking to somebody on Sunday at the speaker reception, and he was saying that he really, you know, hates economics because, you know, he's from a country in South America, and the IMF came in when he was growing up and completely screwed up the economy, and so he thinks that economists are useless. So there are different kinds of economics. I'm not going to talk about the IMF or macro, so I'm talking more about microeconomics and game theory. And this is really all about understanding how people make choices, right? So the fundamental study of economics is sort of how do people make decisions, whether it's rational or behavioral or somewhere in between. And then how do we use this information to design economic systems that work better? And one of the fundamental differences I see between this point of view and the point of view of a lot of the project teams we work with is that many project teams assume that their users and their miners are going to do what they want them to do. You know, so it's sort of, there's an action that's obviously best for the platform, like we really want people to come and not steal money from other users, so we're just going to assume that that's what they're going to do. Right? Whereas for someone who's been trained in an economic point of view, you really have to show that that's what's going to happen, right? You can't just assume that people are going to do what you want just because it would be convenient for you and your platform. And over the last 30 or 40 years, you know, it used to be that academic economists and economists in general just studied how people make choices. And about 30 or 40 years ago, economists realized that they could actually use this information to design more effective platforms. And a lot of this took place in the tech space. But we realized that, you know, now that we understand what kinds of mistakes people make, how they respond to different mechanisms, we could use this information to help economic systems behave in the way that we want. And one particular field that gets a lot of attention is called market design. Is anyone familiar with the term market design? One person, all right. Has anyone heard of the FCC Spectrum auctions, where they auction broadband? So that's an example of market design. I'll talk about some more. So market design is all around us. And I think a lot of people don't realize that, is that many of the markets that we use on a regular basis that we find to be efficient and useful and friendly to use are that way because a large number of economists have run a large number of experiments to figure out how they could be better designed. So a couple of examples. eBay. eBay is my favorite example of good economic design. They have an army of economists, and just everything nothing on the eBay platform is left to chance. Everything from the length of the auction to whether the auction has a fixed end date to how search and structured browsing work have all been designed and are there for an economic purpose. And one example is the resolution center. So that's what this is here. If you have a dispute with someone that you're transacting with on the eBay platform, there's a very well advertised and well-defined process for how to minimize the amount to which you are taken advantage of, right? And so if you engage in a transaction on eBay and it doesn't go the way you want, either you don't get paid or someone didn't send you your good or something else, you can go here and very quickly someone from the eBay platform will step up and help you solve your problem. And this is a very expensive service. It requires actual humans. eBay is a for-profit company. They don't provide this just because they want to be nice. This provides trust in the platform, right? So there's an economic reason why dispute resolution is being provided. Another type of economic design we see is actually reflected in things like recommendation engines. So I'm sure many of you are familiar with the Netflix recommendation engine. This isn't a two-sided market per se. This is a user deciding what they want to watch and having the platform suggest what they might enjoy. But this was also introduced with an economic motivation, right? So when Netflix was originally introduced, you just go to the site and you'd look for whatever you wanted to watch. And the problem was that the catalog was so huge that unless you were a cinephile and knew exactly what you were looking for, you were completely overwhelmed. And so what Netflix found was that people would look around for like 30 to 60 seconds or a couple of minutes, and if they couldn't find something they wanted to watch, they left the platform, and then they canceled their subscription, right? And so the Netflix recommendation challenge, the contest, and the implementation of this were introduced again for an economic reason. Netflix, I've seen estimates that this has saved them $1 billion in canceled subscriptions. And really, these are just two examples in the non-blockchain world of where thinking about what are the economic transactions that are going to take place and how can we make them easier for people and avoid cognitive mistakes and build institutions that help engender trust can really help users get the maximum value out of what the platform is trying to achieve. And so I entered this field from a non-blockchain world. Academic economists, for the most part, haven't really caught up with the concept of blockchain yet. And so I was very bought into this idea of economic design, right? Once you see it everywhere, and you think, oh, okay, this is really great, and everyone should be using these tools. But what I found is there's sort of this, very freedom-loving contingent in the blockchain community, as we all know. And there tends to be a feeling that, design is the same thing as restricting freedom. So people say, I don't want to design platform. I don't want to restrict people's choices. I don't want to institute, these types of procedures where a third party can step in and mediate a dispute because that's freedom restricting. And what you actually see when you do these types of design projects is that it's really not about restricting people's freedom. It's about giving them the tools so that they can use your platform effectively, right? A lot of economic systems, when they lack any structure, they're really difficult to navigate. You need a lot of information. There's complex decisions to be made. And so providing this type of economic design makes it easier for people to get value and to direct people to do what you need them to do for your platform to be successful. And so, we work with a lot of blockchain native startups and also projects in enterprises. And we've thought really hard about how do we communicate the various aspects of economic design to people who maybe don't have formal training in economics, who have deep knowledge of technical aspects, they have deep knowledge of the industry they're working in, but maybe, intro econ was not super exciting. And so they just, it's a lot to take in. And so what I show here is, this is our economic house. And what we really lay out here is sort of what are the different components of structuring an economic platform, especially one that's blockchain-based. And so I'm not going to go through this in its entirety. We've written about this ad nauseum, happy to provide some recommendations for reading. But sort of at a high level, the point here is really that you need to build an economic system based on what it is you want to achieve, right? So typically when we're talking with project teams, they come to us and they have some kind of value proposition, right? They're coming from the specific industry, they have some kind of technological advance, and they say, okay, here's what we're trying to do. We've raised a little bit of money. Where do we go from here? And I don't know if any of you had this reaction, but one thing you might say when you look at this is, well, how come tokens aren't the entire thing, right? So you'll notice that tokens are the bar sort of right below the roof, and then there's a whole bunch of other stuff. And one of the main messages of economic design is that tokens are a useful thing, and they're particularly novel in this situation. But there are many, many levers that can be used to design incentives, that can be used to design an effective economic environment. And so we have to think about sort of how are individual transactions designed. For any of you who have had sort of a standard job, you could think of transaction design as the contract you work in, right? You've agreed to do some kind of work in exchange for pay, and maybe you have a performance rating, and maybe you have a bonus, or you get, vesting of shares after a few years. That's all a form of contract design, right? And so any economic interaction is going to need that kind of design in order to make sure the transaction works out well. You have to think about the design of marketplaces. I mean, an auction is a pricing mechanism, and there's lots of other kinds, right? You don't have an auction to go down to Herb and Bird or whatever the restaurant is and buy a sandwich, right? They use posted prices. There are bargaining. There's other types of pricing mechanisms. How's your marketplace going to work? What kind of information are you going to provide to people so that they can know who to transact with and how things work? And then building on that, you introduce tokens and then governance, which we heard the previous panel talk about before. And so this is really sort of a layering process. And each of these is something that there are probably 4 or 5 Nobel Prizes for each one of these boxes, except for tokens. No one's won a Nobel Prize for tokens yet. But these are really sort of deep and rich areas that can be used to help provide a useful economic environment. And so I was originally going to go through every one of these boxes in this talk, and then I decided that was an absolutely terrible idea. Happy to talk about them more later. But instead, I want to talk about 3 lessons. I think by now we've advised a couple of dozen different startups using this general framework. And there are sort of 3 meta lessons. And I think one of the things I've noticed is that because so many people in the blockchain community are so mathematically literate, that they tend to jump right into the details, right? So we've met so many people who have really read up on auction theory, right? And they're talking about, second price auction and Dutch auction and all these other pieces, and they really get into the details. And so I think it's almost more useful to offer sort of some more high-level insights, because the math is going to come, right? The math and the theory are going to come. What are sort of the higher-level pieces? So the 3 things I want to talk about are, first, that economic design is a well-tested process. The second is that economic design needs to be customized. And the third is that, unfortunately, there's actually no magic bullet for design. So this is what I'm going to cover for the rest of my time. So the first piece, we talk to many platforms, and one of the things that's so amazing about blockchain and also very frustrating is that these are new economic environments. And so we get asked, all right, well, no one's designed a blockchain platform like mine before. We're inventing new types of platforms all the time. How on earth do you know that what you're designing is going to work, right? How can you say that you can conduct economic design, or that anybody can conduct economic design on my new platform that has not existed before? And this is actually a problem that's been addressed. There are many, many examples of economists being called in to design platforms that have never been designed, that are humongous, multi-million or billion-dollar marketplaces. And they figured out a pretty well-tested procedure. There's a process that they follow, and you see these common patterns over and over again. So here's an example from medicine. Do we have anybody in here who's a medical doctor? No medical doctors. Anybody know someone who's been a medical resident? Okay, we got more, probably a third of people. So in the US, once you finish medical school, your first job after medical school is called a residency. And in the US, you get your residency through a centralized matching algorithm. So the National Medical Residency Program, that's the right order, around 1900 decided that they were going to have all graduating medical students assigned to their first job through something that looks less like the Gale-Shapley algorithm, for those of you who studied operations research. And this has gone sort of in and out of use. So they call it the match. And so the match was used for a while, and then the algorithm would break down, and no one wanted to use it. And then it would come back and sort of go in and out of fashion. Sometimes people would use it, and sometimes people would ignore it. And in the mid-1990s, the match, which had been doing very well, started falling apart. And the reason was actually very interesting. So in the 90s, by this point, the gender balance in medical schools was about 50-50. And there were all these medical students who were getting married to their classmates, right? So they'd go to medical school, they'd meet their spouse. And it turns out that you couldn't enter the match as a couple. You had to enter as two individuals, and you could be assigned anywhere in the country, right? So understandably, there were a large number of people who said, thanks, but no thanks, I'll go find my own job. And so you'd have people withdrawing from the match, and they'd try to find their own position. And it turns out this is actually worse for them. They were ending up with worse jobs if they had gone through the match, because it's so time-intensive to search for a position, especially if you're doing a national search, right? So the match was actually good for the welfare of the doctors, just not when you ended up in a different state than your spouse. So the NRMP called up a professor named Al Roth, who then was at the University of Pittsburgh, and they said, Professor Roth, we know that you study the theory of these markets. You've actually written about our match before. Our match is falling apart. Can you come in and design us a new algorithm? And so he kind of looks at his phone, and he goes, okay, crap. No one had really done this kind of market design before. But it seemed like a really great opportunity to prove that all of this game theory and operations research was useful in the world. So what was the process that they followed? First, they took a good look at their theory. There was a ton of OR theory, a ton of game theory about these types of marketplaces. So, looking across the literature, what were sort of the key themes? What seemed to be the key driving insights that shaped sort of what a good, well-functioning marketplace would look like? But that's only step one, right? And I think that, if this is all I was telling you, if we were stopping here, I agree with you that you should just say, please, stop talking, don't tell me about this anymore. But that's not what they did. The second thing they did was they collected observational evidence. So they said, okay, where in the world have we seen labor markets using these general types of algorithms? And these weren't perfect matches. It turns out that there were different medical labor markets around the world that had done variations of centralized matching, and they had all kinds of different algorithms, and they were all a little bit different and strange. But they existed. And so they said, okay, collecting this observational evidence, can this tell us anything about the hypotheses that we've gotten from our theory? And in general, sort of pointing in the right direction. And the third thing they did was that Professor Roth and his team designed the proposed algorithm that they wanted to use. And then they ran lab experiments. They actually went into what is sort of a psychology economics lab and tested the key mechanisms. And yes, this is not a multi-million-dollar labor market yet, but we're moving more and more towards evidence. So they ran a number of experiments to see if the mechanism that they were going to propose was going to give results in line with what they were looking for. And then they launched. And it turns out that the algorithm that came out of Professor Roth's team has now used in over 40 labor markets. It's been used in many other settings, which I'll talk about in a little bit. It's very, very well established, and it works very well. And we'll sometimes meet medical doctors who really, really hate the match. I think there's some feeling that it's, having someone else choose where you're going to live can be a little hard sometimes. But this really is welfare enhancing for doctors compared to looking on their own. And now there's an effective algorithm that people use. And if you talk to anybody who's done other kinds of design, I mean, another great example of this is the FCC Spectrum auctions, where a group of Stanford and Caltech economists were called up in 1997 to design the auction for broadband, which is a very complex combinatorial auction. And they, in a completely different setting with completely different people, followed almost exactly the same process. So there's a way to go from designing your theory, as in any setting, designing your theory, collecting evidence, starting to test it before you shoot it out into the world. And, you don't just have to cross your fingers and hope that it works. So the second piece I want to discuss is that, this type of design is extremely customized. And one of my favorite topics in blockchain is the topic of governance. And originally I sort of think of governance phase one as a lot of what we were hearing about on the panel where there wasn't really much thought to governance. And so either you have core developers making decisions on behalf of the community, or you have sort of a central leader that everybody looks up to, but there's not sort of a well-defined governance process. And more recently, as platforms have realized that they need to develop governance processes, they've started to take what they think of as governance from other settings. So the type of thing we'll see is, oh, well, majority rule voting works really well for pieces of our government, so we're going to take that and we're going to use it on our platform. There's sort of a lot of copying and pasting. And the second piece sort of you can take from these types of design projects is that copying and pasting usually doesn't work out very well. And I like to refer to it as borrowing somebody else's suit, right? So like suppose you really, really need a suit. And you're on short notice. You might be able to go and borrow somebody else's suit if they're sort of the same size as you, but it probably won't fit you that well. Like the sleeves might be too short and the pants might be too big. And you would not borrow a suit for usually you would not borrow a suit for your own wedding, right? You wouldn't borrow a suit for a very important occasion. You really want this type of thing to be custom designed. And this is true for economic design in as much as it's true for velvet dinner jackets in James Bond movies. So I mentioned before that the algorithm that was originally designed for the residency match has had success in other locations. So it's been used in over 40 different labor markets for medicine. It's also been used in public school matching. So here in New York, in Boston, and a couple other cities, there's actually centralized matching systems to assign K-12 students to schools. And I think in New York, it's like kindergarten, 6th grade, and high school. And what this is supposed to do is it gives students an opportunity to attend high-quality schools outside the zone where they live, right? So you want to give every student in New York the opportunity to attend a wide variety of schools. How do you assign this? It's through this centralized algorithm. And similarly to the medical match, in the late 90s, the New York public school system had developed their own algorithm to match students to school positions. It really wasn't working. Something like 1/3 of the students ended up without a position in school. So they'd run the match, and 1/3 of students, they'd just be like, well, sorry, you didn't get a spot. So after the school board heard about the success with the residency match, they called up Professor Roth, who by this time had this giant team across a whole bunch of different major universities, and they said, that algorithm that you designed, would it work for us? So the team comes in and they look at the fundamental structure of the market and they say, hey, actually, yes, we think the fundamental mechanism could work, but we're going to have to change some pieces of it. And so, they tweak different pieces. There are some schools that have special criteria for being able to apply to enter them, and some of them have score cutoffs and all that other kind of pieces. They had to figure out, do the exam schools get put into the match, or are they separate? But there was also sort of a fundamental, slightly different emphasis on what the design of the market was trying to maximize. So in the residency match, the residency match, tries to be doctor-friendly, but it's really sort of a labor market for adults. Most people entering the match have advice from their medical schools, and sort of you enter and you figure out where you're going to go. Here, we're thinking about how do you allocate one of the most precious public goods, which is a position in public education. So there's an overwhelming emphasis on making the mechanism understandable for parents, safe so that they can trust it, and amenable to families. For example, you might want to be able to go to the same school as your older sibling. You don't want your parents having to drive all around the city to get people to 3 different schools. So the algorithm, while the base was the same, it's been adjusted over time to allow for things like, having preference in a school that's within walking distance, or being able to go to the same school as your older sibling. And so there's really an element, of understanding the fundamental structure, but then also tailoring the design to its specific purpose. And finally, I want to end with the most encouraging of the 3, is that there is no magic bullet. And so what I've described to you in terms of designing an entire economic system is a very, very challenging problem. Even for something as complex as, Amazon marketplaces or eBay or some of these marketplaces that we're used to, blockchain's a whole nother level, right? You're really thinking about sort of building an economy from scratch, and this is a very challenging problem. And what we sometimes see is, instead of, this is a difficult problem to grapple with, so what we'll see is people say, okay, I'm going to solve all the incentive problems on my platform by introducing a native token. And by introducing this native token, this will automatically align the incentives of the various users of my platform, and so they'll do what's in the best interest of the platform. And so, that's how I'm going to solve the design problems I'm facing. And a really good example of this actually is token curated registries. So do we have familiarity with token curated registries? How many people have heard of them? Okay, again, maybe a quarter? Got it. So token curated registry is a decentralized mechanism for making a list. So for example, in Los Angeles, up until recently, we only had one major food critic, Jonathan Gold, and he was the word in what restaurants were going to succeed in Los Angeles. So supposing you wanted to say, this is really, he has too much power, let's crowdsource a list like this instead, you could use a token curated registry. And the way a token curated registry would work, in short, there's variation in design, would be something like this. Let's say we want a list of restaurants. We're going to have people vote on them, but we want them to be good restaurants, not just anything in Times Square. So here's what we're going to do. We're going to introduce a native token. In order to vote, you have to buy the token. People want the token to go up if they're holding it, the value of the token. So because the holders of the token want the value to go up, they're going to vote for good restaurants, which is going to attract more viewers. And then restaurants are going to want to get on this list, so they're going to buy the token, and then the value of the token is going to go up, and everybody's going to be really happy. And when I first read about TCRs, I was very impressed because this is really, really complex, right? And my question was, wait a minute, how do we know this is going to work? Right? For each of these different decision points, I want to know sort of what are the different options that people have, and is doing this actually going to give each actor in the system its best payoff? And it could be that this design works for specific use cases, but I need to show that. And a lot of times you'll see sort of, well, we assume that this is going to work. And so you really have to go through and say, is each person's best interest to do what I desire that they do for the platform? And typically the answer is no, and you have to use many more levers. And this is something that I've seen talked about, not just in theory, but in practice. I think last year I was at Ethereal and ran into somebody who was working for a token curated registry that was a list of media outlets. And they had launched, and I said to him sort of, how's it going? How are you doing? And he was despondent, and he said, you know what? The TCR I work for launched, and the users kicked off the New York Times. This is supposed to be a list of elite media outlets, and they've booted the New York Times, and we have no recourse. We have nothing left to do. So for whatever reason, these users found it was not in their best interest to do what the platform wanted, which was to keep the New York Times and the Wall Street Journal on this list. And so just to conclude, there's this famous quote by John Maynard Keynes, who's a father of modern economics, which is that if economists could manage to get themselves thought as humble, competent people on a level with dentists, that would be splendid, right? And a lot of the approach to economics that I've been talking about today and the economic design takes really is sort of at this, this detailed level. How do we build tools that will help individuals achieve what they want across a wide variety of settings that can be customized. And I'll just end with, typically you want to go to a dentist early. It's better to go to a dentist early than later. And similarly, it can be in your best interest to talk to an economist earlier rather than later, so you don't need an economic root canal. So anyway, this is just a high-level overview of some of the issues we've seen in economics. As I said, I'm Stephanie Herder. I'm from Prysm Group, and happy to talk further about economic design or the industry, so please don't hesitate to reach out. Thank you.